So I gave you a few questions in the last video on graphs of waves and a few things for you to have a crack at. In this video I'm going to work through the solutions to you and tell you exactly how to approach these questions. Quick refresher for you. First question was sketch the following waves. So I gave you two standard waves. I just wanted you to have a sketch of them between these set limits. And the second one was to take a wave equation that involved a combination of trig functions, so 2 cos x minus 3 sin x, put it in the form of a wave equation, and then sketch it from there. So let's have a crack at these. So the first one was 3 sine of x minus 30 between 0 and 360 degrees. When we're doing one like this, we have to think back to our graph transformations and what they're there and what they're going to do. First transformation we have to look at is this one here. Now it's x minus 30 within the sine part. What that tells you is it's going to affect the x-axis. Now remember, something like this affects the x-axis and it moves at 30 degrees. And because it's a minus, it moves at 30 degrees up the way. So we know our sine starts at 0. In this case, our sine is going to start there at 30 degrees. And it's then going to have the same shape as it normally would. So it's then still going to have a curve that comes down there like that. It's going to have a curve that goes up there like that, down to its minimum, and then to there. Now it won't go right back up to the x-axis. Yes, it will eventually as it goes through its period, but when we're working with it and we've limited the period, what we're able to do is then just stop it at that point when it's at the equivalent height of there. And that is a limit at 360 degrees. That's when it reaches there. We then have to figure out all the key bits of information we need to mark on it. So we need to figure out how all of the key points have transformed. So our maximum, our minimum, and our other x-axis intercept. So this one was at 180 degrees. It's moved up 30 degrees. It's now sitting at 210. Our maximum was at 90 degrees. It's now shifted along to 120. And our minimum, which is down there, was originally at 270. It's shifted up 30 degrees. So that's now at 300 degrees. So we've marked on all the key bits involving x. The next thing we have to do is mark on the key bits involving y. So what are our new maximum and minimum? Well, this depends on the part here, what we're multiplying it by. So we're scaling this up by 3. So our maximum used to be at 1. It's now going to go up to 3. And our minimum used to be at minus 1. It's now down at negative 3. And that's what the curve looks like. We can't forget to label the axes and label the curve. Tell us what it's called. So in this case, it's y equals 3 sine of x minus 30. So for this one, we have to do the same sort of approach. We have to think to ourselves, how does the graph transform, what transforms it, and how does it look now? So the first thing to look at is this part of the transformation, the x plus pi by 2. Now x plus pi by 2 shifts it in the x-axis. But remember, we're adding on the pi by 2, so instead of shifting it up the x-axis, it actually shifts it down. So our cos graph starts at 0, and this start is going to go down by pi by 2, which is about the equivalent of 90 degrees. Think where the rest of the key points on the cos graph are. The next one's a root at 90 degrees, so that shifts down to here. So it's actually going to start at 0, and it's going to follow the general way a cosine curve looks after that. It goes down the way, back up and round, and then to there. It almost looks like a negative sine curve, if you like. Now each of these key points have all shifted down 90 degrees, or pi by 2, from where they were before. So this one here is now down at pi by 2. This is at pi, this is at 2 pi, and the maximum is now at 3 pi over 2. Next thing we then have to make sure we label is the maximum and minimum. Well, the maximum and minimum of 5 cos of this is just 5 times the maximum, 5 times the minimum. So the minimum is now at negative 5, the maximum is now at 5. Last thing we need to make sure we do is label it. So y equals 5 cos of x plus pi over 2. That there is the curve we've just sketched and how we've got it. Now that's the basics of graph transformations. We've covered them before, but what happens if we're given the curve in a different form? We have to then manipulate it and then we do our graph transformations. Well, it's actually quite straightforward. Imagine we had this one here, write 2 cos x minus 3 sin x in this form and then sketch the curve. Well, we've done this. We've done writing it in that form already. We've done curve sketching. It's just combining the two together. So to write this in this form, the first thing we have to do is start with our expansion of the k cos of x minus alpha and work from there. So k cos x minus alpha expands and gives us k cos alpha cos x plus k sine alpha sine x. And we can equate this to here looking at the two coefficients. So my k cos alpha is going to equal the 2, and my k sine alpha is going to equal the negative 3. Now from that, I can use that to get an expression for my tan alpha. So I can say fine, so tan alpha equals sine over cos, so it's negative 3 over 2. And then the CAS diagram comes into play again. Where's my solution? What am I looking for? Well, cos is positive, tick tick, sine is negative, tick tick, and tan is negative, tick tick. This one's got the 3, so it's in this quadrant here. So I have to take the tan, minus 1, of 3 over 2, and then subtract it from 360 degrees. So that's how we find our tan minus 1 of negative 3 over 2. When I do that, I get an answer of 303.7 degrees. So that there's my alpha. I then have to figure out the k. Again, we know it's just the coefficients squared and added together. Then we take the square root, so it's 2 squared, plus the negative 3 squared. 2 squared is 4, 3 squared is 9, so it's the square root of 13. So that's what I know the value of k is. So from that, I can then say, fine, so 2 cos x minus 3 sine x equals square root of 13 cos of x minus alpha, which is 303.7 degrees. So there we go. I've now got the form that I can use to manipulate it. What I can now do with that form is sketch the graph. So I can set up my axes like this and then sketch it how I need to. First thing to look at is the x transformation. So x minus 303.7 takes the graph and shifts up by 303.7 degrees. So I start at 0 at a maximum of 1. So my maximum starts there at 303.7. Then the curve goes off the same way it would normally, either side of it. So up, down to there, up to there, and to there. Now remember, this height here matches the height that's there. All right, it has to finish at the same height it started at. Once we've done that, it's then the key points. So the first thing we have to look at is each of the key points on the x-axis. So each of the key points of the roots. Well, we know this one here is shifted from 0 to 303.7. That's perfectly fine. This one here, that was our x-axis intercept initially, has shifted up to 213.7. This one here that was occurring at our minimum has shifted to 123.7. And this one here that was our first root has shifted down to 33.7. So I've now got those. It's then looking at the maximum minima. Well, again, maximum minima of the original cos is 1 and negative 1. So if I do root 13 times that, that's just going to stretch my graph out and put my maximum now at root 13 and my minimum at negative root 13. Then we have to make sure we label it. So in this case, we know y equals root 13 cos of x minus the 303.7. So there we go, we've sketched it. So we've used our transformation first, we've then sketched it, and we've then made sure we do it correct. So that's how we approach questions like this. Here's hoping you got on well with that. I'll see you in class for a bit more help.